Welcome back to the AEC Hive, where we're talking about innovation in architecture, engineering, and construction. I'm Ralph Montague, Director at ArcDocs and co-founder of the AEC Hive.
Hi everyone, this is John Egan, CEO at BIM Launcher and co-founder at AEC Hive. Looking forward to today's discussion.
We're very excited today to have Matthew Jackson with us from BIM Object. Matthew is the Director of Business Development at BIM Object. He's an architect and he calls himself a digitization geek. Matthew, you're very welcome. Do you want to give us a little bit of a background about yourself and how you've got to where you are before we get going?
I could talk about this forever, right? But let's keep it short. I've had a really interesting, career life. So always wanted to be an architect when I was growing up. Super excited about being an architect and went to university to do that. And I graduated very near the financial crash, the big one in 2008. So I ended up finding myself in tech, and I found myself getting really interested in this BIM thing around 2010. And I ended up finding this little Swedish startup called BIM Object back in 2014. And I've been there since and just trying to solve the digitalization problem. Digitalization geek, I think, is a really good way of saying it. I get really excited about really geeky data stuff and digitization processes, and I need to get out more. I think COVID means I need to go out and drink more beer, to calm down.
That's fantastic. Maybe just picking up on the name of your company, but yeah, it's something that I've always been interested in, is this concept that we can consider buildings and infrastructure at the object level, at the component level. Because I think previously, as an architect who's worked, for many years in all mediums, drawings and CAD, and you're always considering the whole building, the whole piece of infrastructure, and your work was involved in producing general arrangement drawings, and so you're working at that sort of macro scale almost. But with BIM, we discovered the power of working with buildings and infrastructure at the component level. And it's something I've always been fascinated about. And, when you think about buildings and infrastructure at the component level, well, then there's a lot of repeatability because, of course, everybody has this argument, buildings aren't manufactured because every building is bespoke. But when you look at the components of buildings and infrastructure, of course, those aren't bespoke because building products, building materials have to go through many years of development and testing and everything before they get to the market. So what actually goes into buildings is quite repeatable across all buildings. And with BIM, that just sounded like such a great concept that you could take repeatable products and materials and reuse them over and over again throughout projects. But I don't think that's actually happened in practice. I find architects and engineers are drawing, if you like, the same components over and over again across projects across the world.
So I agree. I think there's a big concern, right? So I'm really fortunate. I get to lecture at two architecture universities, and you come in and young people, they want to learn about the industry, and you get the lecturers who don't really understand what BIM is. Let's be honest. Sometimes you start talking about these things, and the easiest way that I explain it is that instead of drawing something, you want to take a load of little Lego bricks and then build your design from tiny little Lego pieces. And those Lego pieces are standardized. And I think the big kickback that you get straight away from the architecture community is but that means all buildings will be the same. And it's well, no, that's not really the case. You can take the example, if you have 6 2x4 Lego pieces, right? The most standard Lego brick, the first Lego brick that was ever invented. If you have 6 of those, you can arrange those 6 bricks in 915 million different ways by collecting them together, right? So there is no argument that common components or having these common design elements will stifle design creativity. I think that's the first big leap we have to get ourselves over. And then I think you'll start to see, I don't think we're ever going to get, I was speaking to somebody the other week, they were comparing, when you go and configure a car online. When you go and configure a car online, you want to buy a new car. You feel like I'm designing my own car. It's common elements, common platform, but it's controlled within a factory. And you build it in a factory and then you place it into the environment and the environment moves around. I don't think we'll ever get to that point with buildings. You do have to accept that every site is unique. Like it has unique problems, roads, how you get electricity in and out, people. But there's definitely a common elemental part to it. which should be considered. I mean, we've done work with Ministry of Justice, we've done work with supermarkets, we've done work with, with large organizations who are actually trying to standardize their spaces. And then they give the spaces to architects and go, here's my standard design space. Here's all the elements that will be in it, but I need you to arrange them for the site and make the site work, make the entrance work, make the common spaces work, make it functional.
Focus on the design.
Focus on the design and not worrying about disabled toilet details, which I remember doing when I was an architect for a college. You don't need to worry about that. You just need to put the elements in place and worry about the impact of the building and the flow of the building, and like all the cool stuff that architects want to do. To be honest, it's kind of weird they're fighting that battle.
Yeah, and I mean, a lot of architects are spending enormous amounts of time on tedious, mundane type of work. How can I say, creating these generic objects, and then having to go and in the first place, and then having to go and make a decision ultimately on what type of product is going to be used, and then going to following that up with getting all the certification and all the technical information that demonstrates compliance with various regulations. And every single architect is doing that on every single project.
And just think that's
what an enormous amount of wasted time.
Yeah, I just think that's going to get critically harder as we move forward. So as we move forward, it's like, I'm gonna throw the sustainability grenade into the conversation straight away, right? So if you look at what Denmark and Sweden are doing, so in Denmark, Copenhagen had this big, we want to be the first carbon neutral city by 2025. And what happened was that in Danish legislation, they went, right, from 2023, so basically, right, it's 1st of October today, so 15 months from now, you cannot get planning consent for a building which is over 500 square meters if you do not deliver the carbon impact of the design and when it's in use. Just think about that. So they want life cycle carbon analysis, because the reason they want that is because they can't calculate the carbon neutrality of the city as a living, breathing city without understanding what carbon impacts are going to come into the city with new buildings or infrastructure or whatever you want, right? So going back to what you just said there, Ralph, which is really interesting. Imagine doing this uniquely every single time, arranging products and spaces uniquely every single time, and then trying to work out the carbon impact of that for every single building. I mean, you're talking like tenfold the amount of work that you're going to have to do today. And that's just to answer one question. We're not even talking about long-term maintainability of buildings, mass customization of buildings, recycling of buildings. We're not even discussing that. We're just talking about carbon, one thing. That's tough to do.
It's very tough. And I suppose it's particularly tough, if each product manufacturer is presenting their information in a different way. Yeah. So, I mean, as an architect, I'm just using that example, but you're comparing 2 or 3 products and you're trying to make a decision, okay, which one is better? And so you have to do that. You have to look at the performance data across a number of attributes in relation to that product, including carbon and how carbon is counted. And then if each of those manufacturers presents the data to you, well, firstly in a static format that you can only read with your eyes, and secondly, each one is sort of presenting it in a different way that they're measuring it, and it just becomes incredibly difficult to compare and contrast. Well, I suppose on one hand you might say maybe the manufacturers are doing that purposely so that they that people can't do a direct comparison, and throwing that in there that
maybe but I mean
maybe certain manufacturers don't want their products compared with others because they might be shown up to be inferior products, whereas if they cook the books, if you like.
Maybe, but I mean, I think we've also struggled with like the standards of what that is, right? I mean, like, so in Europe we have obviously EPDs, so environmental product declaration certifications, right? And there's actually multiple different ways that you can measure it. And then but how do you present that information up to the industry that's useful? So this is always my big thing, right? If a manufacturer has their information in PDFs, you come to the problem that you just said. How do I manually look at it with my eyes and identify what's best? A PDF, at least the information is there, but it's not useful from getting that information either into a modeling process or to choose the right product from a specification process. One thing that we're trying to do BIM Object, one thing that I'm really passionate about is how can we make the life of an architect and a specifier easier? So, I mean, an architect basically wants to create the best possible building that they want to create, and that includes the products. The specifier wants to make sure that they specify the right products for the project while having cost in their mind. And then the client wants the best possible outcome. And I mean, we have one client who we're helping today who, for every building, spends between 1.5 and 2,000 man hours going over PDFs to identify what are the best products to buy, because they run very critical infrastructure. And we've identified that actually, if you have all this in a database of information, then you can shortcut a lot of these problems. The problem is having the manufacturer's information in a common database and have it accessible and usable by the architectural, engineering, construction communities. And whether that's as a BIM object or whether that's as a data set or both or either is kind of where I think the industry is going and where we're kind of evolving into. I mean, you know.
Yeah. And also the amount of work, that sort of checking compliance work is being done multiple times. So, for instance, the architect has a professional responsibility to specify products that meet the regulations and various criteria and environmental performance, you know, if they're designing a building to a particular standard. So they obviously going through a lot of work doing that checking. And then on the other side, the client, you know, wants to satisfy themselves as well that that their building will meet the standards that they want to achieve. And so they're probably doing a bit of that checking as well. You know, and everybody's checking the same information over and over again. And mostly because it's uncertain whether that information that is being presented is validated. So, so if an architect gets some information, they're not sure where they got it from. Maybe they just picked it off a website, or maybe some junior person in the office just took a generic object and started populating it with some information. Nobody knows. So you have to check it. There's no validation. You know, there's no sort of a stamp on the information saying this is absolutely the right data from the manufacturer.
I think that's a really
authorized.
Good point.
I mean, because if everyone knew that, then you could say, well, at least I don't have. If there's 1,000 objects in my model, and 800 of those have got a little stamp on it, a token maybe, a digital token to say that this is definitely valid and authorized by the supplier, then it will reduce your work, reduce everybody's work.
Yeah, I mean, what we're talking about here is reducing risk and increasing trust, right? I mean, those are things which are sorely needed across multiple areas in the industry. And one thing that we do take very, 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 very seriously is how do we get information from the manufacturers, and how do we ensure that they take responsibility in the accuracy, and how can we track and trace information that's either within the database or within the objects. I think that conversation has been difficult in the past few years, to be really honest. And I think now there is certainly an appetite for that conversation, because there has been, events, unfortunately, in the world where buildings have failed. Of course, we had
spectacularly.
Yeah,
in some
instances, and we had another one in Milan, didn't we, a few weeks ago, very similar to Grenfell, where those questions have to be asked, and we, as an industry, have to take real responsibility at ensuring that the right products are specified at the design phase. I mean, it is absolutely key. And I'm not saying that people should necessarily choose a manufacturer from day one. What I'm saying is that people need to be able to have a specification and then be able to track what products meet that specification. I mean, I think that's really, really, really key, because then you can start predicting the future, right? I mean, like, the whole point of when I was first introduced to BIM in the early days, BIM was explained to me. It was like, Matthew, what we do is we're going to create a complete digital version of the building in a computer, work out whether we can build it, how we can build it, how it will work, and then we'll build it in real life. And to me, you at least need to have an understanding of the performance data of the products. You may or may not need geometric representations of those products for everything. Like if it's a pump, which is behind a wall, no. But if it's a window, a fire door, yeah, probably quite good to have that accurate geometric representations of those, so you understand where everything is. But at least get
even the pump behind the wall, you do need to. Firstly, you need to
know where.
it there.
Yeah, and you need to know the access point, the ins and outs. So
if the pump fails, and so I think location data, and location is in 3D space. So location of objects, even if they are hidden or behind walls, those objects still have to be installed there, and they at some point in time they may need to be found.
And they're part of this.
But that's an important point you brought up about trust in data. And John, maybe you can come in here, because I mean that is a big issue. There's so much data flowing around and being shared and copied and pasted. Nobody knows. Firstly, where the data originated from. There's no way of, seems to be no way of tracking the data, like who's changed it, who's edited it, who is the originator. Yeah, I mean, designers might think they're the originators, but again, if we go to that idea that buildings are collections of objects, most of the data around the particular components should have originated from the product manufacturers, but probably doesn't. John, we've had lots of conversations about the exchange of data across environments and how to track and trust data. I mean, that's what you're doing, I suppose, with BIM Launcher is trying to track, the data. I mean, it's probably not what people are doing at the moment, but you would imagine in the future that every manufacturer would have its common data environment that is then sort of connected, if you like, to every project that uses those products. Yeah. That's not what happens at the moment, but
I think it obviously comes back to the intent of the originator with the data. And, from our perspective, when we connect these disintegrated systems, we are doing our best to maintain the integrity of the information as it's exchanged from designers' hands into contractors and down supply chains hands. We're doing our best to maintain the information and the originator intent as it exchanges hands, with a view that this will produce a higher quality digital representation of the building, and thus might be able to be leveraged in a better way throughout the building life cycle. It's interesting listening to you guys talk, because all I can think of is blockchain, as a solution to actually creating a ledger in which building products essentially get their trust characteristic from. So at any point during the life cycle, you could click on an object, copy paste the UUID into the blockchain or into the ledger essentially, and double check where that information came from, and also if the integrity of that information has been altered.
So that's interesting that you said that. So we did a little skunk works a few years ago around ledger technology, and one thing that we understand is that products in buildings can change specification all of the time. Even really simple things, from changing a tap from chrome to gold, right? The most simplest of things. And those decisions in the design process or the specification process, of course, get lost. It's very, we let's really be honest here. We will never document an architect going, oh, I've changed the color of something. Or I've moved that from the left to the right. We're never going to get to that minutia. So I think ledger tech is quite interesting. So we did a little skunk works where we wanted to move from ArchiCAD into VR into Revit and back again, and use like some translation technology. And what we wanted to do, we just wanted to prove that if somebody did a design in ArchiCAD, we beamed it up to a VR system, and they were like, oh no, I don't like that tap. I don't like it. I want it gold, or I want it, and that shower fitting I want changed to the other shower fitting. And what we did was, when things were moved or things were changed, we were able, because we assigned GUIDs at an object level, we were able to assign a change log, a ledger of change, and who made that change and when they made that change and in what system did they make that change. And we were able to do that. We were able to record these changes at that level. That technology is just sitting there doing nothing right now, because complicated, I think, is the easiest way to say. But I kind of agree, really, like, but also, do we need to get to that point? Do we need to get that far down the road? Or do we just need to understand, like, general design change? Like, because I'm going down to, like, the most minutiae of adjustments now, in that way. Is that what you mean, John, or do you mean kind of like broader?
Yeah, that's it's exactly hit the nail on the head with that Skunkworks project. That's exactly what I was proposing. Any change in design would come as a result of a decision, and the individual or organization that made that decision should be responsible for the decision. In order to track those changes, blockchain seems like the most suitable technology available because of its immutability characteristics. You make a decision, it's on the blockchain. Fair enough, if you come back a week later and say, hey, I want to change it back, you can make that change back, but it's still going to be on the blockchain. You know, to your tap example, and one thing that Ralph and I often bring into this is some of the techniques used in software development. What we use, particularly when we're talking about code changes, which often reflect features within our software, is this concept of semantic versioning. So what we do is leverage this framework to say that if there's a major change, like complete change will break everyone's down chain kind of designs and decisions that they've made around the top level software, we would have that as, you know, a major design change. Then we'd have minor design change, which would be something that was inside the bounds of the context that everyone was thinking, and doesn't necessarily break it will break smaller decisions that have been made downstream. And then obviously the third level then would be even more minor changes. So what I'm thinking about in terms of your example is, if you change the shape of the bathroom, you know, to a 1 meter or 2 meter by 2 meter block, if you like, you're not going to be able to fit in a bath. You're not going to be able to fit in so it would break everyone's decisions that have been made at the next level around which bath to use, etc. And then if you were going to make a more minor change, you could, like, such as the tap on the bath, that's a really minor change. So you're kind of, it's just about employing these techniques for collaboration around this complex thing, which is a building. And what makes it complex is all the decisions that's gone into it, and how that's represented in a framework. You have
to think about the amount of products that go into a building. I mean, you just the product types is in the thousands. When you talk then about individual products, you know, if you want to start counting the individual bricks and blocks and taps and scales, and like the individual elements that go into a building is just huge. And going back to the beginning, the start of this kind of area of the conversation, increasing trust and decreasing risk. If we design the best building possible, what should that entail from a design point of view? Are we just going to design something which is generic and elemental, or we can design something to go at least have specification to say, no, you need to build the building using elements which meet this performance criteria? The architects and the engineers are really good at that, like especially when you get to the engineering level, where they go, right, you need a heating and cooling system which meets these specifications to ensure maximum efficiency for the building over a lifespan of X. But then when we hand over that information to construction companies don't actually buy much material apart from the concrete. It seems like they'll hand that down to their supply chain, you know, to to the fit out crews and go buy stuff which meets the specification, that decision then all of a sudden hops over and hops down the line. And kind of I think the question that the industry has to ask itself is that who should be making the product decisions? Should an architect and engineer say you have to buy that? Or should there be, you have to buy that which meets that specification, and then how do you check that within a system? Because different suppliers, different manufacturers, every product has a nuance. Every product has potentially a different place where you connect it within a system. And if an engineer has designed a system where all the pipes run a certain way, but you pick a manufacturer where the pipes have to go in from the back, not the side, for example, then you potentially have to do all this solving on site situation, which then of course is extremely messy, and that's what creates all of the problems. I don't have answers to these questions, but I think these are the problems which kind of exist. And we're saying is that, well, first of all, at least use the information that's being presented. And, we are working really hard on presenting as much information as possible in as many different ways as possible, so it's useful. But I still think there's that fundamental question over who makes the decisions around the elements of a building. Is it the architects and engineers, or is it this? Yes.
Well,
I mean, I don't know if you guys have been following the Grenfell inquiry, but it's fascinating. Just the circumstances that arose that the particular cladding system was changed, from what was specified by the architect, and that change wasn't picked up, and that led to a disaster where 70 people lost their lives, and it's basically that change was all buried in paperwork, so had somebody the time to go through all the paperwork, they probably would have picked up that change had occurred, but probably just didn't have the time to do that. And this is where you think, well, technology could help, because like computers don't mind thousands of bits of information. They actually love working with millions bits of data points. That's what they're designed for.
There aren't many humans which enjoy looking at huge Excel spreadsheets and working out if they look correct, right? I mean, that's not what humans are designed to do, I don't think. Yeah.
So I suppose what you're saying there, Matthew, is as we go through this process, and an architect or an engineer, determines a performance criteria, and obviously that's their job. Their job is to make sure that the products meet a certain performance to meet the building regulations, and they have the best understanding of what compliance and everything means. I mean, the purchasing clerk in a contracting company doesn't have that sort of experience, and they're probably only thinking about price.
Yeah, and also and this is where the big, sorry to jump in here, but also this is the big controversy around public sector and private sector. So in private sector, and again, we work with Scandinavia's biggest supermarkets. As a private sector client, they already have a very defined supply chain. So we help them standardize refrigeration spaces and all the units that go in there. And then basically they have 3 different refrigeration sizes for the supermarkets, and you just place it into the design. And it's all standardized. Brilliant. Fantastic idea. And you have a very strict supply chain around that. The problem then, you flip it over to the other side, is in the public sector, where everyone goes, yes, but you can't use manufacturer information because it's public sector. It has to go to tender. And I'm like, well, why not? Because what is the harm in saying this or similar? At least you're testing a building that's going to be built with something that's real or exists. And you've gone, I found this. This is the best product I think would work for your building to run efficiently over 50 years, which is when we're asked to design or build a school, we're asked to design or build it for a 50-year lifespan, but we take no understanding or account of the cost of that over 50 years. We just look at the building cost. And then we go, okay, well, I found these really cool products. This will really work over the 50-year lifespan. Oh no, but you can't say that. You just have to specify and just say, it needs to do this. Well, why not? Just say or similar. It does kind of mess things up where people go, oh, you can't go and use manufacturers' data.
Isn't the reason that the private sector are doing that is because the time that it takes to determine if a product meets their needs, takes quite long. And
Yes.
so once they've worked through that, they're saying, well, I don't want to have to do that again. So that's
And
it.
if they
I've
find
decided,
a good one that works, you
Yeah.
just copy and paste.
Yeah, so I've decided that's what I'm going to use, and you can use nothing else, because I don't want to have to go through that procedure again of testing another product. And I do understand in the public sector that you have to allow competition. That makes sense.
Absolutely. I'm not saying
it's kind of like open BIM versus closed BIM, proprietary versus being open. So I'm quite for the idea that things should be open and people should be able to compete in the market, and therefore the approach that you described in the private sector there isn't. It's more proprietary, and it's not allowing for SMEs in the market to participate and demonstrate their ability to meet the performance criteria. Whereas, so I'm actually for the more public sector approach where it's open, but the challenge is demonstrating the compliance.
Yeah, I'm sitting here nodding on a podcast and realize that no one can see my face. No, I'm not saying that the public sector should become proprietary. I'm saying that surely it is better for the design to design something based on real things. And then when it goes out to tender, you go, okay, we based it on these real things, but you still need to go out to tender. You still need to go and find that product or product from an SME, and because an SME can come into a market and create one or two products which are amazing for performance, and no architect, no specifier knows every single product in the world for what they're looking for. There are so many companies producing so many amazingly good products all over the world, and you're never going to know all of them, so you're always going to miss out on.
One of the things about technology and some of these ideas that we're talking about, ledgers and blockchain and authorized and trustworthy data and everything. Well, one of those things, what some people might see as a negative, is it creates a layer of transparency, which maybe the market isn't ready for, because I think a lot of people are selling stuff, marketing stuff, maybe even knowing full well that their product is inferior and doesn't meet certain criteria or specifications. But if you present it in a certain way, you can sell it. And if people don't have the ability to check or confirm whether your product is inferior, then they might buy it. And as soon as we start saying, well, now we've got to standardize data and performance and the variables that you use and the way you calculate certain things, and I think that's where things are going. I think in Europe there's initiatives, the smart CE marking initiatives, even the standards that are being developed for product data at the European level. I think that's where it'll go. But I'm pretty certain there's a large number of people who don't like that idea, because it will expose the inferior nature of their product, which they've been able to overcome with marketing. By
and also
having a good marketing engine.
Like shortcutting maybe manufacturing processes or quality processes, right? And don't for people who are listening, don't take this the wrong way, but if you think about the commoditization of products, not just in construction, everywhere, in every industry, right? TVs, shoes, bricks, whatever. It's in a lot of cases it's been a race to the bottom, right? So how cheaply can we manufacture it where it still has some kind of performance and that people are willing to buy? It goes back to that, you get what you pay for trope. And I think one of the big struggles that we've had in the industry is that we get budgets set for building buildings. I've designed schools and hospitals. You get set a budget and it's like, we want you to spend this much money per square meter. And it's like, okay, but that means that, am I trying to build a bigger school as possible for a budget, or am I trying to build the best school as possible for the budget? And one thing that having all this data does and understanding performance is we can now calculate long-term building cost. So one of the fascinating things that have always kind of really frustrated me about the industry is that how many CapEx, capital expenditure, so the cost of building, and operations expenditure, facility management, how often do they sit down together and say we're going to build a building? It doesn't really happen. And it's kind of like, but if you, and you know, I've been talking about this for years at conferences, and I actually do a slide presentation where I've taken two products from BIM Object, they're water pumps. And I've made up the data, and I've gone like, this one costs 10,000 euros, and these are its performance. This is how long it lasts. This is how often you have to replace it over 50 years. And this is option B. It costs 20,000. But over 50 years, that 20,000 euro product costs twice as much from CapEx, but actually costs 33% less on OpEx, because it's got a longer life. You have to maintain it less. It is more energy efficient. It's more performance efficient. So, and we've never been able to calculate these things before, really. No, without the information from the manufacturer.
Well, even if you can, sometimes the challenge is the capital budget is somebody else's budget to the operational budget. Yeah. So, like even the capital, whoever's managing the capital budget will say, well, that's not my problem. It's, I've got this budget. I have to do my work within this budget. And if it costs the operational team twice as much, that's their problem. So it's almost like there's a layer above that's missing, saying, well, actually guys, we're in this together.
So that layer, So that layer now exists, because what I thought would happen is that people would kind of key on to how much a building costs to run. And this goes back to my sustainability big argument. And that is sustainability, I think, will be the thing that will push this into the forefront, where what the sustainability mandates are going to do is they're going to say you need to run a building to be, as low energy as possible, right? To be as thermally efficient as possible. And that is nothing to do with cost. That is to do with performance based on, not having the planet burn to death, all of us, because, the temperatures are rising. So therefore, if you want a building which is more, energy efficient, usually you have to spend more money. You have to go and find better performing products, which cost more. And incidentally, therefore, the side effect of making a building more sustainable, in theory, is that it's actually cheaper to run over time, because you're using less electricity and you are transferring less waste energy out of the building. So it's kind of done this really weird journey where, and this is kind of like, I'm having really interesting conversations with architects in Denmark and Sweden, because they have this mandate. Like, they're starting to realize, like, so I'm going to start specifying a building which costs more, but actually does cost less over time as a side effect, but is more sustainable. So that CapEx, OpEx argument could be solved from something quite unexpected reason, to be honest. Kind of thinking about it now.
Well, maybe if you didn't pay architects to do tedious, mundane tasks of creating and drawing and generating, I'm going to just call it useless information, because it's information that's going to be changed later at any point, at some point, and then and you instead paid them to design buildings that performed. And if you took out that sort of wasteful activity, maybe you could reassign that budget to more, to better activities, and therefore the better performing building may not cost more, because you've
because you spend
more
time on. I mean, let's be honest. When we all went, when we went to architecture school, I never in a million years imagined that people would be spending hours on end days on end, weeks on end doing these quite tedious tasks. Like you go to architecture school, you design all this cool, crazy stuff, right? You think about space and people and how people use buildings. How do you make people happy using buildings? And that's...
You spend your first 6 months doing door schedules.
Yeah. And yeah, I did door schedules and disabled toilet details. I remember it very, very clearly. And it's like, oh my God, what have I just entered? It's like, I'm full of all this energy and these crazy ideas, and that's what architects are really good at. Like let them be really good at design. Like let them create amazing spaces for people.
I remember when we started working for contractors, and a contractor told me that they never use architects' door schedules because they don't trust them.
What's the point then?
and I was saying, what, like the thing that architects hate the most, which is doing door schedules, and spend so much time doing, nobody uses because they don't trust them. And what the contractors end up doing is sending the drawings to their door supplier and saying, can you make up a schedule of all the doors that you're going to provide for us?
Trust and risk.
We'll
Trust and risk, isn't it? It goes back to that, doesn't it? I mean, it's like, it's just crazy. Like people, the industry is full of such talented people. I think like sometimes we get lost in the way, like we get, like we love to moan about construction. It's one of our favorite jobs to do sometimes. But actually, if you think about it, like it's an industry full of really amazingly talented, smart people. It's just that we get stuck in these really antiquated processes which don't really make any sense. Where like this is where technology can come in and really help out. And I think, this is why, I'm 7 years at BIM Object, and I still believe that it's solvable, to provide all this information to make better design decisions. I really believe in it, and I really believe that it will create a huge sustainable impact, a positive sustainable impact. And I think everyone will enjoy designing a lot more and will be able to get much more efficient buildings. Manufacturers, I think they really want to help. They understand that, of course, they are responsible for their data. They own it. I think that's really key. Goes back to what John was saying earlier, right? Like trust and trackability and traceability and certification. Like they own the data. That's really key. They need to get it and spread it to as many people as possible so it can be used to make better design. And I think that's absolutely key. And it just needs to be easier. I think everything's still challenging today.
Yeah.
There's only so many hours in the day to do work.
I wanted to bring the discussion a little bit on, and I suppose it's related to that transparency and how technology is sort of opening up and creating a transparency. But on the other side of that is smoke and mirrors, and big companies with marketing engines that are sort of convincing people to take on inferior products. And it's not only in the building products arena, it's maybe in the technology arena as well. Some of the technology vendors are putting great stories out there of technology solutions, but they're not actually solutions. Do you see a lot of that happening where people are being sold a pup, if you like?
What are you saying, Ralph?
Technology.
I work in marketing. Are you accusing me of?
Oh, no. Well, I'm asking.
No. I think it's a really good point. It's all these buzzwords which come out, and like companies jumping on these buzzwords, and you can kind of say it from the very beginning. The big architectural design software vendors jumping on the term BIM. And a lot of the industry still thinks, unfortunately, BIM is software and software is BIM. That started from the outset. Things like we're now going through level 3. Level 2. When level 2 came out, people were going, "Oh, my technology does level 3, level 4." Like level 4 doesn't even exist. What the hell is level 4? 17D now, I think, probably. And now we've got like digital twin tech, which is out, and common data environments, which of course John knows lots about. But people are using these buzzwords to kind of, if I'm going to be really honest, like to sell software licenses, and it doesn't really help. It doesn't help move the conversation forward. It doesn't really. There is some amazing technology being produced out there, and it's fantastic and solving huge problems. But of course, you're always going to get the players which use their marketing engines who see these new softwares, these new techs as risks, and they try and cover themselves. And ones which just out and out just don't do what they say. It's not Ronseal, it doesn't do what it says on the tin. It's something very different.
Sector we could look at that have maybe gone through that and come out the other side and said, we started off with all these individual vendors sort of fighting with each other, and then eventually we came up with a solution where we can all work together. I don't know. I'm just probably asking the question. Like, is there a sector that construction could say, well, that sector went through that phase where everybody was marketing solutions that weren't that useful, but they came through that. And
I mean, what usually happens is you get market consolidation, right? Where you get just less and less and less and less vendors offering to an industry, and then you end up with almost monopolization. I mean, I don't think that's ever going to happen in construction, because I think construction is just such a broad industry, which is very different regionally. So I'm not really worried about that.
Well, has it happened in other sectors? I mean, could you say there's a sector like healthcare or finance or
telecommunications,
travel or anything where
comms it's happened in, hasn't it? I mean, well, look at music it's happened. There's only so many players. The streaming wars, I mean, then that's happening now in video, right? I mean, there's lots of players who want to deliver video content to, and obviously it's B2C business, but who want to deliver content, and companies come up and then they merge. And there's just been a merger here in Sweden recently between two of the big, because they clearly can't compete against Netflix. You look at what BBC and ITV have done with their service in the UK. They realize they potentially can't compete with a Netflix, and they need to join forces to distribute internationally. It's starting to see consolidation, which has already happened in music. In communications, I guess the same again, but the communications are very much based on infrastructure, right? I mean, like, you have to have 3G, 4G, 5G networks. Who owns those networks? It's quite hard for a new player to come into those markets, for good and bad things, really.
So when I mentioned telecommunications, what I was implying was that there was a standardization around common concept within the industry. So like what a user, for example, when you call Vodafone, whether you're calling Vodafone to cancel a contract or Three to cancel a contract, or mobile phone service providers here, but they all have the same processes. Okay, you want to shut your account, you want to move your number. Okay, that's a straightforward process to move your number to another provider, different things like that. But the pattern that is common across all industries is that when a concept moves from, and something that we could potentially bring back to the product life cycle as well, and something that I heard throughout this podcast, was that architects are creating products in a custom format. Manufacturers have productized these objects. And one thing that you touched on, Matthew, is the commoditization of these objects. And the thing that enables the product to evolve from a product stage to a commoditization stage is the standardization of the interfaces to do with these product object models. Once they reach the commodity stage, you see new sources of value being started to be developed in the custom stage and the product stage. So they're building on top of these standards. So to your point around the challenge that, these mergers, etc., are creating, I would actually disagree that it's more difficult for an SME to get involved. I'd say it's more difficult for an SME to actually get involved when the product, when the object is at the product stage, if you like. And the reason being is because it's not standardized. So you need to be in the know to say that the interest of the bigger organizations are to keep away from the commodity stage and really keep inefficiency within the process. And that's how they remain dominant within the stage of the market.
So if you look at the interesting work that Bryden would have done on grid standardization within public sector buildings, so they went away and they studied the grids of all the different public sector buildings that we had to try and identify common grid elements. So then you can start standardizing rooms based on grid, because if you take take a bedroom, for example, right? So from a public sector, we build bedrooms for a number of different purposes. We build bedrooms in prisons, student accommodation, nurses, fire stations. There's many different places that army, of course, barracks, of course. We build bedrooms in many different places, but as a public sector, which is one client, holistically one client, you're basically building bedrooms differently for every single sector that you're working to. You haven't standardized your grid. You haven't standardized what a bedroom should be. Now, I'm not saying that there shouldn't be different sized bedrooms, and obviously the elements which go into a bedroom in a prison and a bedroom for a student, I hope are different, because they should be different. But also, there's a difference between army, between a younger cadet and obviously a general again. So but still standardization of grid. One example actually that I thought of when I was just sitting here, John, when you were talking, I think one area of standardization in construction is kitchens. So kitchens run off a 600 grid, 600 millimeter grid, or like part of, right? So you can get a 450 mil dishwasher. The standardization of kitchens is fantastic because, when you're building a kitchen, whether you go to Ikea or you go to, Wix in the UK or H&H out in here in Sweden, you can buy one part of your kitchen from one supplier and then buy another part of your kitchen from another supplier, but it's going to work because it's running off a 600 grid. You can buy the carcasses from one, the doors from another. You can buy your ovens and your white goods from several suppliers. It's all off a 600 grid, all of it. Everything runs off the 600 grid. And that's a really good, and therefore, going back to your comment, John, an SME can enter a kitchen product market quite happily because they know they're going to build the best fridge in the world, right? Let's say like a fridge that doesn't run on electricity. Someone go and design that. But they know it needs to be 596 millimeters wide to fit within the 600 grid to allow for tolerance. They already know what size it needs to be and how tall it needs to be because it runs off a standard grid.
So standardization, that it comes down to that. So standardization makes things work.
Yeah.
And when we often talk about standards on this podcast, and I think people hear the word standards and immediately switch off, and it's one of those words that just gets a visceral reaction where you just think immediately it's something that's burdensome and it's going to be complicated and it's something best avoided. But actually it's the opposite, and you see that throughout the world. Standardization is what makes things work. It's the reason we have drinking water, good electricity, constant communication networks. It's all because of standards. And that's probably the part that the construction industry is still grappling with, is trying to standardize. And even the work that's being done on product data, trying to standardize product data, at a European level, is still in its infancy, I suppose. There's some great work done at CEN TC 442 with the standards, and there's work across Europe to digitize the market with the smart CE marking and various other initiatives. But it's very early days. But it'd be great to see.
And it's early days because you just have to think of the scale which needs to be done. I mean, there's lots of architects and contractors in the world, but now, go down those levels and look at the supply chain and look at the amount of manufacturers which deliver products to building sites. It is tens, hundreds of thousands. I mean, it's something like, I think the Construction Products Alliance, CPA, has something like 55,000 members in the UK, of which 95% of those are SMEs. And a lot of those companies produce produce just one product. They're a specialist in producing something for hospitals. Now, you've got to go out to them. And you've got to go, hey, so there's this big digitization thing happening. We need your data. Just that as a scale is just it's so easy to say, oh, just digitize some stuff. And
isn't the problem that everybody's expecting those SMEs to figure it out for themselves, to go and read 500 standards, and
no one's going to go and read TC 442.
Yeah.
So, I mean, I've read it. I've also read, I'm sad. I've also, read a little bit of, ISO 19650 and I did some work on PAS 1192, some of the parts, like all this thing. But that's because I'm interested, but also there's a vested interest in my job. You have to turn around and think about the manufacturers. The manufacturer's job is to manufacture a product as best as possible and to sell it as much volume as they can to ensure profitability. That's their job. That is why manufacturers exist. Going back to your false marketing, I think another false marketing area of where we are is general overcomplication of what we're trying to do. If you want to go and speak to all these people, we need to really simplify the language that we use and be really honest about what we're trying to get people to do. And basically what we're trying to get people to do is we need a data set from you so we can measure a building. That's what we want. That is the most basic level. Right now, we don't have a standard for that data set. So let's take it anyway and let's see what we can do. Yeah. And then when a standard comes along, then we can start doing smart stuff like mapping. But I don't think we should ever expect the SMEs to go do like smart mapping and all those sorts of things. I think they need technology industry-wide.
Yeah. Just to kind of wrap it up, because we are getting to the time. Our theme is innovation and looking ahead. So I suppose we spent a lot of this call looking at the reality or the current situation. Looking ahead and innovation, and in your mind, what is the big gap? Where is the big area of innovation that needs to happen, or is maybe that you see is going to happen soon? Or what's keeping you excited about the future?
For me, it's looking at building something which really does perform to what people want. I mean, construction's about people, right? I mean, we build buildings for people and experience and the quality of building, the quality of someone's home, the quality of someone's office. We've just come out of COVID, which has been terrible. Everyone's been working from home, been working from their beds. How is that going to change the way we use buildings in the future? I really hope that there's like a massive shift. And what I'm really excited about is that I think we're very close to understanding the long-term impact of construction. And construction as an industry produces 40% of all solid waste. So buildings, 40% of all solid waste and 35% of all CO2, right? So we as an industry really need to look at our existing stock and what we build. And we need to be really clever and work out how do we just be more efficient just on the sustainability part. I think for me, that's kind of what makes me really excited. And I think the technology kind of exists now. I think the technology is there. What we're doing, and we're evolving what we're doing here at BIM Object with getting more data into the hands of people that need it. But all the technology around it, the analysis tools, the simulation tools, smart CE marking, factories to build stuff. All that's coming, and I think the output is just a more eco-friendly, sustainable, people-friendly built environment. I think that's what gets me really excited, and I think it's there. I think it's doable. I think the big step is education and understanding where to spend the money. I think that's the biggest barrier to getting there. I don't think I think technology exists. I think it's there. I think there's most of it is already there. It's just people and education and the willingness.
Behavior. John, did you have any final questions or comments or?
Yeah, just the final one there was just something I was dying to bring up on the back of that point there, or that I made around the evolution of the building product and equivalent digital representation into the commodity phase of, I suppose, our market segment. I just wanted to pick up on one of the points that you made earlier that set off an alarm bell in my head, Matthew, around the you don't think we'll ever get to the stage where we're configuring a house or a place that we will live like we configure a new car. And one of the things that standardization brings is the standardization of interfaces, which enable things like the standardization or the configuration of the car. So if you think of it, all the seats, if you like, have standardized rails to attach to the body, and you're essentially switching out what you want, sports seat to standard seat, etc.
I think I may have misspoken then, because that's not what I meant. What I meant was, I 100% want to go online and design my house in some kind of car simulator, right? It's more of the process of building it, the process of how you interact with a site. So like, one thing that will be custom of that design will be probably the foundations because of the soil structure. So that's what I mean. What I mean is you'll never get to like a car level, because a car, it's driving on a road. We know what a road kind of is made of. It's, tarmac is kind of standardized, right? But a house, so you could basically build the house completely in a factory, which has been configured by somebody online with standardized elementation. Absolutely. But still maybe like the foundations are custom, like the water pipes from the mains entering through the land, maybe custom. So like those you'll always have some level of custom within a project, always. And I think we just have to be like, we have to accept that. I think we just have to be like that. The furthest we can get is building a building in a factory, but then placing it on site, and how the site works, of course, will be custom, because most of our roads already exist in the world. Most of the plots of land already exist in the world. Like we're not going to just knock down entire cities, regrid it, and then build it up again. Like that infrastructure kind of already exists. So we have to kind of plug into that infrastructure. That's what I meant. So, but on your point of like the commoditization, I totally believe in that. I totally believe that you should just be able to go into, and Ikea are trying really hard to do this. So in Sweden, go and have a look. It's called Boklok, Boklok. Skanska, of course, are building them. And obviously they've tried a couple of times in the UK to do housing. They're getting there slowly but surely, but they have the same challenges that we all have. Supply chain, just on time delivery, all that stuff is into the factory. It's all there. All that supply chain stuff is still there. And, look at what happened to Katera a few months ago. Again, another company that tried to, they did some amazing things, but they're still kind of stuck within an existing infrastructure. So it'll get there. I believe in fully manufacturable buildings. Just the site is always custom. At least, someone can prove me wrong. I'm very happy to be proven wrong that a site can always be the same. Make life even easier.
Maybe if you're doing a development, number of houses, there could be some of that. But anyway, we've probably gone over the hour a little bit, but it's been a great talk, and I suppose that's always a good sign that we've had a great discussion, as if the time just flies away. Matthew, just want to thank you for your time and your input. It's been a great discussion. I really hope people pick it up and take this idea forward, that we should think about the built environment at the component level, get the information at that level correct, shareable, and that eliminate a lot of the sort of tedious and mundane tasks that people are carrying out at the moment, working with paper-based and generic information.
Absolutely.
So we appreciate your time, and I'm sure we'll be talking again.
Lovely. Thank you much, guys. Have a wonderful weekend.